because that's what we do. So meeting being recorded, and then we'll all just participate. So, okay, so we're gonna go through Unit 4. We're gonna start with multiple choice questions. And then I'm gonna sign in on my tablet so that I can have touchscreen access. All right, so okay, so a student combined two colorless aqueous solutions. One of the solutions contained sodium carbonate as a solute, and the other one contained hydrochloric acid. The chemical reaction that took place is represented by the equation above. What experimental result would be evidence that a chemical reaction took place when the solutions were combined? Okay, so this is definition of a chemical reaction, all right? So go ahead and take like 30 seconds to go through this. Okay, perfect. All right, so let's see. Let's go with Idali. Idali, what do you think the answer is for this one?
I think it's B.
The total volume is close to the sum of the initial volumes. And does that give you evidence of a chemical reaction?
No.
Okay. So is there another one that tells you that there might have been a chemical reaction?
So would it be A?
Yeah, bubbles forming, right? How many of
Okay.
us had bubbles forming?
I did.
Jacob did. Who else?
I did.
Yeah, good symphony. Okay. All right. Mercedes, Marcella, how about you ladies?
Yeah, I had A.
You had A. Good, good. Okay.
Yeah.
Perfect, perfect. All right. So let's take a look at, okay, this is a shorter one, so that's, maybe we can get through this today. Number 2. So a chemistry teacher carried out, what does it say? Okay, perfect. So a chemistry teacher carried out several demonstrations and students recorded their observations. For one of the demonstrations, a student concluded that a physical change took place, but not a chemical change. Which of the following observations could the student have made of the results of the demonstration? So what is this? Chemistry teacher said, student concluded physical change took place, but not a chemical change. Which of the following could the student have made of the results of the demonstration? Okay. All right. Go ahead and give that a shot. I'm just trying to figure out what the heck it's saying. Give yourself like 30 seconds to go through this one. Oh, I see. Okay, so what are the results the students might like? That last question is the question part itself is confusing. Basically, like what results did the student see? Okay, if he was gonna or she was gonna conclude that it was physical and not chemical, the change that took place. What are the results the student saw? Okay, so go ahead and give that 30 seconds. Okay. So, who has an answer for this one?
Is it C?
One piece of solid substance was changed into small pieces. Do you think that's true, Shifa? Is that a physical change?
I have an answer. Oh.
You have an answer, Sinead? What do you
Yeah,
think?
is it
Bro,
A?
Okay, Shifa, what do you think?
I think it's A too.
You think it's A too? Okay, what about you, Mercedes?
I agree.
Okay, so remember, guys, this is saying not a chemical change, okay? So when color changes, we do have a chemical change. So it can't be A, right? What about B? Do
Would
sparks?
it be D?
D, precipitate formed. No, that's a chemical reaction too, because you've got two solutions combining and then something solid coming out of the solutions. So that's called a precipitation reaction. What about this one? Are sparks evidence of a chemical reaction?
Wouldn't that be? No, hold on.
Yeah, sparks are evidence of a chemical reaction. So the correct answer is as Jacob mentioned, is C. Okay, correct answer is C right there. Okay. All right, let's take a look at number 3. A student was given 2 clear liquids, a colorless liquid and a dark blue liquid. The student was asked to combine the liquids. Actually, let's go back a little bit. So what questions do we have? Sinead, I want you to ask me a question. Ask me a question about number 2 here. Question 2. What's on your mind?
No, I understood it. It's just I didn't really think through the first one
Okay,
because at first I was like, oh, it's just color.
so let's think about evidence of a chemical reaction, right? Right? So like, there are a whole bunch of different types, but like one of them could be precipitate, a precipitate forming. Another piece of evidence could be like a change in temp, like yeah, that's like, so a change in temperature that's not caused by an external factor, right? So like some sort of change in temperature that comes from like things being mixed or things being mixed together and combined that's not related to like, so basically absorption or release of heat or release. And you got like color change. You could have bubbles. Like light produced. What else? What else? What are some other pieces of evidence for a chemical change? Anybody? Did I miss anything, guys? Are there any other? I'm sure there are, but did I miss anything big that we've already covered?
No.
These are
Not
pretty
that I can think of.
pretty big. Oh, another one is sound. Sound or explosion. Okay, sound or explosion. Those are totally, and those definitely indicate that a chemical reaction has occurred. Okay, so you just want to memorize those, right? So that you can answer these types of questions, and like more importantly, so that you'll know in real life when chemical reactions are actually going on around you. Okay. Number 3, so a student was given 2 clear liquids, a colorless liquid and a dark blue liquid. The student was asked to combine the liquids in a beaker and record observations. Which of the following results, if true, would provide the best evidence that a chemical change took place when the liquids were combined? Okay, so the 2 clear liquids, okay, colorless and dark blue, and then which one tells you that there's a chemical change taking place? All right, take 30 seconds or so. Okay. So let's go back to Shifa. Shifa, what do you think for this one?
I think it's A.
A, the mixture turned cloudy. Okay. Antonio, what did you get?
I agree with Shifa.
Okay. And then one last. So I'll ask Mercedes. Mercedes, what did you get?
I got A as
Okay.
well.
Did anybody get anything other than A? All right.
I did
Everyone's
not.
right. Okay. What, Caton?
Oh, I said no. I didn't get anything other than A.
Yeah, A is correct. Very, very good. Okay. And what is this evidence of? If the mixture turns cloudy, what does that tell us is happening?
Precipitation.
Yeah, very good. Okay, that's a precipitation reaction for sure. Yeah, yep. End of story. All right. So so I guess not quite end of story. One question could be why. Why is that? Why is that? How do we know that's a precipitation reaction? Because you've got two clear liquids, right? And when you mix them together,
Mhm.
they go from like clear to cloudy. Why? Because inside of that solution, what you've got are little particles that are solid that have precipitated and are now scattering or blocking light transmission through the little beaker, right? So those particles are what make are what makes the solution turn cloudy. Okay, and it's no longer a solution; it's a heterogeneous mixture at that point. Okay, so those are solid particles. So the cloudiness, right, comes from solid particles. Okay, something's turned solid in there. All right, any questions? Okay, we're gonna move on. So let's take a look at number 4. So which of the following is the correct net ionic equation of the neutralization reaction between hydrofluoric acid and sodium hydroxide in aqueous solution? So like, remember how this works, right? Like if you have some sort of ionic equation where things are getting mixed, you have to get rid of the spectator ions, okay? So the spectator ions should be gone on both sides. For instance, if I have like Mg, let's go with MgCl2 plus NaOH, right? That's going to yield MgOH2 plus 2 NaCl, right? But on both sides of this, the sodium and chlorides, let's say this is a solid, right? And that this is aqueous, and then everything over here is also aqueous, right? So if that happens, if this precipitation reaction happens, right, then you actually want to get rid of the chlorine and you want to get rid of the sodium there, right, on all sides, so that you can look at just the net reaction. So magnesium plus 2 hydroxide yields magnesium hydroxide. Okay? So that would be a net ionic equation. I know that was fast, but we've seen this before. So go ahead and apply that here. Okay, question 4, which of these is the net ionic equation? Welcome, Rainisha. How are you?
Hi, Dr. J. I'm sorry. I forgot we start at 110, not 210.
It's okay. I'll mark you present, but tardy. I actually had you marked present. Sorry about that.
Mhm.
I should always know that you're here or you're not. Okay. Okay. So, all right. So, okay. So we're doing this question, Rainisha, number 4. Which of the following is the correct net ionic equation for the neutralization reaction between hydrofluoric acid and sodium hydroxide? Okay. And I'll give us, well, I think we know what hydrofluoric acid and sodium hydroxide are at this point. So go ahead and take your time. I'll give you guys let's take like a minute and a half to work through this. I'll pause the recording. Okay, so we're trying to figure out which one of these is the net ionic equation, right? And so if you look at these guys, the state indicators aqueous tell us that the aqueous components or the aqueous chemicals are broken apart into ions. So those are ionized in solution. And so I don't have a lot of real estate here on the screen, so I'm not going to put the state indicators, but all these H plus, F minus, Na plus, and OH minus are indeed aqueous. And then your products are H2O liquid plus Na plus F minus, right? And so what we have to do is we have to cross out the spectator ions. So like F minus is present on both sides, it's got to go. Na plus is present on both sides, it's got to go. So then we get H plus OH minus gives H2O liquid. Is that what you got, Sinead? Is that how you did that?
Yes, that's exactly how I did it.
Okay, let's see if that's the right answer. That looks good to me. Man, that's a small equation. Oh no, it's D. How do we miss this guy? So D's the right answer. So how do we miss this guy? So HF aqueous plus OH minus gives H2O plus F minus. And what's the, oh, because they're saying, oh, right. Okay. Oh, this is great. Okay. So here's how we got goofed. So Antonio, why did you pick that one? And how did you get that one instead of the one that we got C? Take us through your thought process. Good job.
Well, I thought HF wasn't gonna fully dissociate
You're
down to
right.
HF plus F.
Because HF is a weak acid. You're absolutely right. Good job, Antonio. Nice job, right? See, I had to miss that one. Nice job. See, you got to really pay attention to the details here. Good job. So let's go back through that one from the beginning. Really good. Okay. So what happens here? So you got HF aqueous, right? And it doesn't dissociate. HF, okay, it's dissolved, but for the most part, it's not ionized. So some component of it does ionize, right? But most of it's not ionized because it's a weak acid. It's not a strong acid. So that's the issue. Plus NaOH, so Na plus OH minus yields H2O plus Na plus. Now this is an ionized species, sodium fluoride plus F minus. Okay, and so then your spectator ions become Na plus, and that's it. It's just Na plus. So this is exactly what happens. Really nice job, Antonio. Okay, so Nate, your reasoning was spot on. In the for the case of a strong acid, the problem is that HF's not a strong acid, so we both we both got tripped up on that one. Okay, so yeah, so that's that. Okay, that's the net ionic equation. That's a good problem. Okay, kudos, Antonio. Very nice job. Any questions, scholars? Okay, let's move on. Oh, that's great. Okay, so number 5. Which of the following is the correct net ionic equation of the reaction that occurs when aqueous solutions of ammonia and hydrochloric acid are combined? Ooh, okay. So big difference here, right? We're dealing with hydrochloric acid. So what does that mean, okay? Hydrochloric acid and ammonia, net ionic equation. Good luck. May the forces be with all of you. Take a minute and a half. Okay. Okay, so Kate and I agree on this one that ammonia plus HCl, where HCl ionizes because it's a strong acid, yields ammonium NH4 plus Cl minus. So the chlorides are the only spectator ions, so they go, right? And then we should really get B as the answer. Let's see if that's the case. Woohoo! Okay, B is the correct answer. All right, so any questions, scholars, about this one?
Wait, so Dr. J, from what I'm seeing, it's like you kind of have to already know what these compounds add up to in order to like do it. Because I'm a little confused as to like how you can just break it down from what we have right here. So is it just like a thing where you're gonna have to like know what NH3 plus HCl equals?
I mean, it pretty much tells you in the problem, right? So like you might have to do that on a free response question. So you might see it like that on your AP test. But a lot of these are like chemicals that we've worked with over and over. So we're just going to see them so often that we should know this from our practice, right? But if you look at this one, you can pretty much tell what's happening, right? Like you can see like, okay, here's what's going on, right? So like NH3 plus HCl, sure enough, forms ammonia, right? And then Cl just kind of gets tacked on there. So I would say yes. And like the way to do that is to review your notes and to look at the stuff that we've studied to this point, because we have spent a good amount of time looking into this kind of thing. Or am I off on that one? Have we not spent as much time on this kind of thing as I think we have?
No, we have. I was just wondering, like in the case like we're asked, or or in the case that we see something we're not necessarily like used to.
Try to look at the answers themselves and see what makes sense.
Okay.
Okay. Here in this case, you can pretty much tell that ammonium is forming. Like there's no answer choice that doesn't have NH4 plus in it. So you got to say to yourself, okay, that's going to form for sure. What's the spectator ion? Oh, the spectator ion is chloride. I cross that out and I'm left with B. Okay. so let's take a look at number 6. A beaker was half filled with freshly distilled water and placed on a hot plate. As the temperature of the water reached 100 degrees Celsius, vigorous bubbling was observed in the beaker. The gaseous contents of the bubbles were analyzed. The presence of which of the following substances would support the claim that the observed phenomenon was a physical change? Okay, physical change. All right, so go ahead and take 30 seconds and think through this one, okay? Go ahead. All right, so here we are back at it. So, what do we think? I want to hear from, let's go with April. April, what do you think the answer is here?
I got C.
You got C, carbon dioxide. So if carbon dioxide is what bubbles out of the water, that's the indication that there's a physical change happening?
No, that's a chemical. Wait, sorry.
That's a chemical, right? So this question's asking physical change. So which one of these would indicate that there's a physical change happening?
Would it be D?
Yeah, right? It's just another form of the water. It's a physical change. Boiling, okay, evaporation is a physical change. What are some other physical changes that we've talked about?
If you like freeze water, that would be a
Freezing is a
change.
physical change, good. Then is melting a physical change?
Yes.
Yes.
Yeah. What about when you put a glass of ice water on your table and a bunch of water forms on the side of it? What's happening there?
Isn't that like condensation?
Yeah, but what's happening at the molecular level during condensation?
It's turning into a liquid.
What's turning into a liquid?
The
You got a glass, right?
yeah.
It's
And
melting.
got some water and you got some little ice chunks, right? Okay, and they're floating, right? And then all along the outside, there are these little bubbles that form, these little like droplets, right? These little beads of water that form along the outside of the glass, right? Little condensation droplets, okay? And so what do those form from? Mercedes, can you help us out? Where do those come from?
Wait, what was the question again?
Where do those condensation bubbles come from on your glass of ice water? How does your ice water come to have condensation on it?
The heat?
Heat?
The precipitation thing?
Precipitation? Okay,
Yeah.
what do you think, Sinead?
Heat.
Heat, okay. Jacob, what do you think? Are you here?
Yes, I'm here. What's the question?
How would you explain this?
Oh, I would explain it because it's doing a form change, but there's no like chemical reaction. It's only changing the physical aspects, such as the way that you would treat it.
Okay, so this is a physical change, but how is it occurring? Why does this happen? Why do like droplets of liquid water form on the outside of a glass of water, ice water? Like, why does that happen?
Because it's absorbing heat.
It's
taking
absorbing
from the-
heat. Okay, Antonio, what do you think?
Well, the moisture around the glass, like the water,
Uh-huh.
gets like cooled down when it
Okay.
touches the cold surface.
Good. And where is that moisture? Is that moisture liquid somewhere, or what phase is it in?
It's just in the air.
It's in the air. So is it a gas?
Yeah, it's gas.
Yeah. So the gaseous water in the air, okay, these particles, these water particles, they collide, right, with this with this glass, and they get cold, right? They cool down, and they go from the gas phase to the liquid phase. When they go to the liquid phase, right, they coalesce, they condense into droplets. Okay, so this is condensation. These water molecules were floating around in the air. Okay, they were in the gas phase, and then they condensed into the liquid phase on the side of the glass of water because the glass of the water was cold. Okay, so that's what's happening there. Does that make sense?
Yes.
Mercedes, how do you feel about that?
Okay.
You feel good about that one?
Yeah.
Okay, so Nate, does that make sense to you too?
Yeah, it does.
Okay.
Wait, Dr. J, like this is kind of related, but like hypothetically, can't you get like condensation on the rims of like hot things too? Or is that just from the steam that
No, that's from steam. Yeah. There's
Oh,
no
okay.
condensation happening there. Yep. Okay, and then the correct answer here is D, right? You're just changing the state. Okay, D is totally correct for number 6. All right, number 7. Whew, okay, so mass of sodium iodide crystals, color of the crystals, color of the solid recovered, color of the filtered solution, mass of dry solid recovered. Okay, so when students added 2 grams of sodium iodide to 100 milliliters of lead nitrate, a yellow precipitate formed. After the solution was filtered, the yellow solid was dried and weighed. The data from the experiment are shown in the table above. Which of the following claims is best supported by the observations? Okay, so go ahead and take some time to think about this. We'll take like 3 minutes and then we'll chat as a group. Okay, so what do we think? I'm gonna come right back to April again. April, what do you think here?
I was thinking B.
B as in boy. It's a physical change when the color of the sodium iodide solid added change to yellow. Okay, and then let's go with Idali. Idali, what do you think?
I don't think it was a physical change, so I was thinking it was a chemical change, and because of the yellow compound that was added, I just thought that it would be C.
C. Okay, what's wrong with D? How did you rule out D?
I just didn't think that the covalent bonds would break when drying. I just thought that
Are there covalent bonds here?
no.
Why not? How do you know that there are not covalent bonds?
Is it because it's not soluble or something like that?
So what do we have here in sodium iodide, right? Now water is held together by covalent bonds, the water molecules themselves, but I'm focusing on this compound, right? What kind of compound is this? Is this a molecular compound, an ionic compound, a metallic compound? What is this?
Metallic, I think.
Metallic, sodium. Is iodine a metal? Sodium is a metal. Is iodine also a metal?
I don't know.
Okay, take a look at your periodic table, but who can chime in right now to help out? Is iodine a metal?
No, it's not.
Isn't it
No,
a liquid?
not a metal. What is it, Idali?
Wait, I'm checking.
Okay.
It's a halogen, if I'm not mistaken.
That's right, Kaiten. It's a halogen. So Idali, is a halogen a metal or a non-metal?
Non-metal.
Non-metal. So what happens, thank you, Idali. What happens, Mercedes, when you get a metal and a non-metal together in one compound, right? You have sodium iodide, the compound. What kind of compound is that?
Is it ionic?
Shifa says, is it ionic? Do you agree, Mercedes? Is that an ionic compound when you have a metal and a non-metal?
Yes.
Yeah. So then that's what's going on over here, right? Like you don't have like the yellow solid, whatever it is, right? Whatever's happening here, we shouldn't be thinking about covalent bonds within the context of these solids. Okay, so sodium iodide, that's an ionic compound, right? This yellow solid, we should actually expect this to be lead. This should be lead to iodide. So PbI2, and I should write that too there. PbI2, right? So that should be our yellow solid, okay? And this solid over here, lead to iodide, that thing's held together by ionic bonds too. So we don't have any covalent bonds holding that together, okay? So Idali is correct. The correct answer is absolutely C, okay? This is a chemical change. You've got a color change happening. And so whenever the color changes, we know that there is a chemical change, okay? There is a chemical change as evidenced by the color change, all right? Other questions, scholars? Okay, so I'm gonna go ahead and clear the board and we're gonna move on to the next question. So you've got this one. So a student carried out a titration using, that's the HC2H3O2, that's acetic acid, and sodium hydroxide, NaOH. The net ionic equation for the neutralization reaction that occurs is represented above. The sodium hydroxide was added from a burette to the acetic acid in a flask. The equivalence point was reached when a total of 20.0 milliliters of sodium hydroxide had been added to the flask. How does the amount of acetic acid in the flask after the addition of 5.0 milliliters of sodium hydroxide compare to the amount of acetic acid in the flask after the addition of 1.0 milliliters of sodium hydroxide? What is the reason for this result? Okay, so go ahead and think through this. All right, give yourself, let's go with 2.5 minutes, okay? Hey Siri, set timer for 2.5 minutes.
Okay, your timer is set for 2 minutes and 30 seconds.
Okay, so Shifa, what'd you get for this one?
I think I'm going with B.
B, it's the same, okay? And then what did you get, April?
I was between B or D.
B or D, okay? Mercedes, what about you?
I didn't get an answer yet.
Okay, April, how about you? Or sorry, not April, Marcella, how about you?
I didn't get an answer either.
Okay, what'd you get, let's go with Jacob. Jacob, what'd you get here?
I got A.
A, okay. Jacob, how'd you get A?
I was thinking A because with the titration, as you're adding, so that's because more, okay. As you're adding more HC2H3O2 to it, it's gonna neutralize more of the base or the acid.
That guy gets deprotonated and turns into acetate, okay? So you're gonna have, so this OH minus is reacting with the acetic acid. So the more of this is added, the more of this reacts, okay? And the more of this forms, the less of this guy remains. So A is correct, okay? And Eva, you got that too, didn't you?
Yeah, I got that because it said to compare the values, and in one of them it's greater, so I just knew that it was gonna react more. And it's
Yeah.
So
the more of this you've added, 5 is more than 1. So if you've got more of this, you've got less of this. Okay? Very, very good. Does that make sense, everybody, or do we have questions about that? Okay, I'm going to move on then. Feel free to shoot me a question in the chat if you'd like to PM me instead of asking in front of the group. That's fine too. Okay, so question number 9. So
Wait, Dr. J,
yeah.
are you gonna show us any
What now?
shoes?
You want to see shoes? Okay. Let's do. Oh, we've only got 5 minutes left, huh? Okay.
Yeah.
So let's do this problem, and I'll show shoes at the end of it. Okay. But actually, am I even ready for shoes right now? I can't remember what I have and haven't shown you guys. I'll dig a pair out. Go ahead. So do this problem. Okay. So potassium sulfate aqueous and nitric acid aqueous produce potassium nitrate plus SO2 plus sulfur dioxide plus liquid water. According to the balanced chemical equation above, when 100 milliliters of 0.1 molar potassium sulfate are mixed with 100 milliliters of 0.2 molar nitric acid at 30 degrees Celsius in 1 atmosphere, the volume of sulfur dioxide produces 0.24 liters. It is assumed that the reaction goes to completion. Which of the following changes would double the volume of SO2 produced at the same temperature and pressure? For each change, assume that the other solutions and volumes remain the same. Oh, okay. So this looks like a stoichiometry. This is obviously a stoichiometry problem. So, okay, give it a shot. Take 2 or 3 minutes. Okay. Yeah, I think so, Antonio. That definitely wouldn't be wrong. Yeah, that's what I got, Symphony too. All right, so take a little more time. Okay. All right, so I've got one more answer through the chat. Yeah, Jacob, I think so too. The only thing that makes me uncomfortable is I haven't done the stoichiometric calculations. I haven't multiplied everything out to see what the actual molar ratios are. But that looks like the only decent answer to me. So let's take about another couple seconds here to just think through it. Okay, and then let's go with. Let me see the chat. Okay, so Symphony, why did you choose C for this one?
I chose C because, well, I figured that if you want to double the volume of something, then you would have to double like the entire reaction. And so I know you can't double just like A, for example, just says to double 1, which was the K2SO3, which didn't make any sense because that would be like, yeah, it just wouldn't make sense if you want to double an entire reaction to only double one thing. And the rest kind of followed suit, or they changed like the molarity or anything. So C was like the only one that made sense because it just doubled the volume.
Yeah, and you have in the equation, you can see that you have a 2-to-1 molar ratio. So it makes sense that their concentrations are 2 over here to 1 over here. So doubling the volumes of both makes perfect sense. So that's why C is actually a really good answer choice. So the stoichiometry was done for us, or the concentrations were calculated for us. So C is correct. Okay, C is correct. Any questions about that, scholars? Okay, I'm going to stop the recording. We'll resume on number 10 tomorrow.